Okay. Okay. All right, everybody. Welcome into class as we get started here. Hopefully, we'll see some more people kind of entering in as we progress here. I'll take rolling a little bit. Really appreciate everyone on the YouTube stream throwing their name in there, so that'll just make it that much easier when I go through and do roll in 5-10 minutes, something like that. We'll get to that. So a couple things that I wanted to mention. So where are we at? Oh, here on the, let's see, why is it not scrolling? Here we go. So remember, in fact, maybe I should move it down. Let's move this down here. That's a good place for it right here. So the project survey questions. So those are due the 6th. I need to get that survey out to all of you as soon as I can so that you can actually take everyone in the class can take the survey. We're going to be real low because we have this is a low enrolled class, so we're not going to have nearly as many responses as we'd like. Maybe I'd see if I can get maybe even get my other classes to take it for extra credit or something so we can have more results in the class. But I need to get that out because we're going to be progressing, and the whole idea is the project makes a lot more sense and also is easier to do if you're doing that part of the project at the same time that you're covering that material in class. So like when we're, pretty soon here, we're going to be doing scatter plots and correlation. Well, it's a whole lot easier to do that part of the project while you're learning the material than it is to try to remember it 2 months later and go back and do a good job. So like hopefully you'll remember and you can go back and you'll find ways to improve your work, hopefully before kind of like the work you do now along the way should kind of be viewed as a rough draft. But then, when there's a few weeks left of the semester, your project will have a really good rough draft, and then you just go over it again and go, oh, I can improve this graph, and I can make this sound better, and I can do this a little better, and just make it that much better. So it's really important that we get that survey out and that you all take it, and I can't do that until I have your survey questions. Okay, so please don't forget that date. Make sure you're taking care of that. Remember, everyone needs to leave a post. If you don't leave a comment in there, you don't get credit. So you can't say, oh, Sarah took care of it, I'm in her group. You have to leave a post too. You can split the questions up if you want, so everyone has different questions. That's fine. And then there may be a bit of noise today. I apologize. If it gets to be too much of a distraction, let me know. There's electricians all over. They're working in different parts of the house today, so you might hear some of that noise. And then my dog is kind of nervous because of people working in the house, so I have it's a 7-month-old dog here in the room with me, so he doesn't get nervous. If he's making too much noise, I can move him downstairs, but I think then he might bark a lot. So anyways, I apologize for any noise. If it gets to be too distracting, let me know in chat, and I'll see if I can move my puppy downstairs or something like that. But he shouldn't whine too much, and it should probably be okay. So, but let me know if it's an issue. Okay, let's see. Wait a couple more minutes for roll. We got a few more people in here, which is good. So, yep, make sure you're doing this part of the project. Make sure you get those survey questions in. It is graded, and really, these discussions are the easiest project points you're going to get. These ones along the way that are worth 10 points, those go into your project score, and as long as you go in and do a decent job, you get full credit. Okay, so like 10 out of 10. If you give a decent response, you'll get 10 out of 10 on these discussions. The final project is graded a little bit harder, meaning get these easy points now. Don't let one of these assignments go by and then you're like, darn it, I just missed out on 10 points, because these are the easy 10 points. Okay, the points you get at the end you have to work harder to earn those points. So make sure you have these easy ones early on. Okay. And then we'll do that. And right. And so we're moving through Chapter 3. You have a few more days on the Chapter 3 material. Shouldn't be too terribly difficult. Most students are doing pretty good. I'm getting some questions. I'm getting some questions still with the frequency diagrams, but most people are kind of able to go through it. I do want you to remember that when you're doing a homework problem or a lesson, down at the bottom, there's those there's those options for help. Okay, so one of the help options will tell you what you need to do in StatCrunch to do what you want. And of course, you can still come to me and ask. But if you click it says like more help or something like that, and then there's one for StatCrunch. If you do that, it says, here's how you do the problem in StatCrunch. Like, here's what you click, right? Also, you can just Google stuff. So if you're confused on how to do a specific thing in StatCrunch, you can just Google StatCrunch cumulative frequency distribution or something like that, and then you'll be able to go through and they'll have like a 2-minute video that you can watch on how to do that particular thing. It's also listed in the homework assignment. So two ways where you can quickly get that help that you need in order to get your assignment completed, right? And some of the stuff's a little indirect. Some of the stuff you have to play around with a bit, but that's what I do. When I haven't dealt with StatCrunch for like at the beginning of the semester, someone asks me a question sometimes, and I'm like, oh, I did that like 4 months ago, but I don't remember. A lot of times what I do is I just look on YouTube, and then I watch the video and go, that's right, that's how you do that part. And so it's kind of the easiest way to get that done. So just be aware that you can do that, but also by all means come ask me for help. I've had a number of students in the stats class that were stuck on a problem, and then I helped them out, and then they kind of moved ahead. So don't be afraid to come ask for help either. Okay, I guess we're good. Go through and do some roll here. Okay. Looks like I got everyone listed in Zoom, and then I got all the names for that people put up in YouTube. So, oops. I put these on 2 different rows. These people should be over here. Oh, now I just put them in the wrong row. Anyways, that's fine. I'll be able to figure it out if I have to look at it. Okay, so let's see. We talked about that, getting the stuff ready, making sure that you get your survey questions posted, right? And I know I had some questions, and that's fine. It's good that you come ask questions. The topic you get to choose as long as it is school appropriate. You can choose choose whichever topic you want, and then ask those questions. And it is important to ask the type of questions that I ask. You can throw in an extra question or two if you think it's going to help your overall work. Go ahead. Don't probably bring 25 questions just for your work, but a few extra questions, okay. I have no problem throwing those in there. But you do want to make sure you hit the types of questions that I put in there. If you do not ask 2 quantitative questions, you're not going to be able to do scatter plots and correlation. That's a big part of the course that you won't be able to address in your project, right? So you want to make sure that you read carefully, make sure you're asking the right type of questions, that they're well thought out, and you're not later going to go, oh, we should have asked it this other way. It'll save you a lot of work, okay? So let's see. We want to make sure we're doing that. And then you've got, like I said, you've got some homework assignments coming up on the 7th. Did we meet again before that? Let's see. 5 days is the 7th. 7th might be Monday. Is that right? Either way, you want to be making sure you're progressing on those. We'll talk a little bit about this last part. Oh, and for those of you who are just kind of nervous about the project in general, once we are meeting in the classroom on a regular basis, most of the time we meet, there will be at least some portion of the time where I allow your groups to talk to each other, and then you can go, oh, I've had this one question, and then your group can help you out, and you can show the group what you've done, and you can say, well, here's my graph, and they're like, oh, that's better than my graph. Let me look at how you did that. And I can see why yours looks better than mine. And then you can all just kind of learn from each other in that process. Okay. So don't panic. You know, if I know people get nervous about it, especially since the project expectations kind of unroll throughout the semester. It's not like you can sit down and do it all now. You have to do it as we progress through the course. And I know that makes some people nervous, but that's okay. We'll work through that. Okay. So where are we? Let's see. Oh, right. We're talking about, let's see, was that where I wanted to start? Yeah, measures of relative standing and box plots. Whoop, it's going to be one of those days where I got to keep switching back the size of this window and everything. Let's move this up. Okay, so measures of relative standing and box plots. So that's basically the last portion of 3.5 is on this kind of stuff that we're going to be talking about, okay? Some of it spreads over into other chapters, but then you'll have that information when you get to that chapter, okay? Okay, so the 5-number summary, when they talk about it, is kind of a traditional. I don't want to say it's out of date, but it's your basic information when you're looking at stuff. So you've got your mean, median, standard deviation. Is it quartile 1 and quartile 2? I forget. But the bottom line is when you do your summary stats inside of StatCrunch, it gives you everything from the 5-number summary plus more stuff. Okay, so don't worry. Don't get too hung up on exactly what the 5-number summary is. I mean, you'll kind of learn about it while you're taking the lesson. But just make sure you understand what those pieces are. Make sure you understand the mean. Make sure you understand the median and the standard deviation when you do those. But as many of you have seen, if you've got a set of numbers here, let's see. Oops. We're going to use these in a minute. I've meant to type these up ahead of time. Okay, so you've got your column here. We go into stats. We do our summary stats. For the column, we choose the one that I just made. And here you get this. So the summary statistics that you get inside of StatCrunch. Hold on. I'm going to have to move my dog. He's whining too much. So just give me 1 minute. All right. You are not being good, buddy. Come on. Okay, sorry about that. Usually he stops whining, but I think the fact that I keep talking is keeping him wanting to get my attention. So, okay, so here we are again. So when you do the statistic, just the summary statistics inside of StatCrunch, it's going to give you the stuff that you need for the 5-number summary and more, right? So you've got your quartile 1, quartile 3. We're going to talk about that today. We should be talking about it today. Your max, your min, those are going to be part of your box plot. Like, so these 4 here are part of the box plot. And then, of course, you've got your median, standard deviation, and your mean, which are super important. You've got n. Remember, lowercase n is always the number of values in your data set. And then you've got whatever the column is. So, you'll learn the 5-number summary as you go through and do that part of the book, but just realize you can get all of it from just going into stats, summary stats, columns, picking your column, hitting compute, and then you get that information, right? I think most of you probably have that figured out by now. Let's see. We're going to use this in a minute, so let me go ahead and label this. And in fact, I want this one to be think is what I want. Let's make this like 82. Okay. So I'm gonna use that as part of an example in a minute. Oops. Someone showed up. Let's see. We have. Okay, Claire, I got you. Thanks. And yeah, okay. So, right. So measures of relative standing in box plots. A box plot is another type of way of visualizing statistics that can give you different information. I mean, hopefully you're recognizing this as you go through and you look at the different type of visualizations that you're learning for statistics. You know, you've got your histogram and a bar chart, and those can seem very similar, and sometimes you can even confuse one for the other if you're not real comfortable with it. But, you know, hopefully you recognize, well, a histogram is for quantitative data and a bar chart is for qualitative data. So every graph has its different place, right? It's hard to say like, well, this graph is not a good statistical graph. Well, there may be times when it's a good tool and there may be times when it's a bad tool. So the box plot is just another one. And it gives us it just gives us a different way of looking at our data set. And if you're practice the box plot a little bit, you can start to see that it also gives us information about the shape of the data. How is our data spread out? But in different ways, right? So when we took the standard deviation, that just gives us an overall measurement that shows how spread out our data is. Well, what if your data is spread out unevenly? So like imagine if you have a skewed graph. Well, the left part of your data might be really bunched together while the right part of your data is really spread out. Well, the standard deviation by itself doesn't really give you that view. So you can look up the standard deviation and go, okay, overall, our data is more spread out in this data set than this other one. But that doesn't tell you that it's spread out on the right side more than the left side. Histograms can be helpful with looking at that kind of thing, but also the box plot can really give you some good information about trying to understand the overall shape of the data that you are looking at, okay? So we're going to get to box plots in a little bit. StatCrunch will do them for you. Oftentimes you'll see people use a bunch of box plots together, which can be helpful, right? Sometimes I think that's actually a great way of doing it is you'll see like 12 box plots, maybe one representing temperatures for each month of the year, and then you can really see that behavior over the course of the year and what the temperatures are doing. You see this in a lot of different settings. We also are going to be looking at z-scores. I actually think z-scores are really interesting because you can do some things with z-scores that there isn't really any other good way of doing, right? Comparing things. So it's a nice, simple calculation. It's like a really easy calculation to do, to calculate a z-score. But also they can help you kind of figure something out that otherwise you just would go, I don't know how to compare these two things. Well, z-scores allow us to compute a z-score for both of those things and then compare them and go, oh, okay, we have a little bit of an understanding here. So one thing that you want to be asking yourself about the calculations that we do in this class is when you do a calculation, you want to ask yourself, is this a calculation that applies to the entire data set? Or is this a calculation that applies to just one data point in my data set, right? So in other words, the standard deviation is a calculation that talks about every single data point in the set. Okay, so it's a measurement of the whole set together. If you take any point out of your set, it's entirely reasonable to think that your standard deviation will change, right? Whereas a z-score is a measurement on a single data point, right? See how that's different? Like the mean is a measurement for your whole set. A z-score is a measurement for one individual data point. And so you want to make sure you understand that, because I'll hear students talking about, they'll talk about this, like in the project when they turn it in, they'll talk about the z-score of a whole set. Well, that doesn't make any sense. Or they'll talk about the standard deviation of a point. Well, you could maybe argue, but that's pretty sloppy language to use. Really, the entire set has a standard deviation that would then apply to each point. So just try to kind of think about that when you're using these tools, because it's helpful to understanding the tool. Does it apply to this one data point or the whole set? A z-score applies to each individual data point. That is, if you have a data set, and assuming that your data points are different, which they usually are, you might get some repeated values, but it's kind of rare, like the data set we looked at last time where I had this hypothetical situation where every single person in the class got 80s. You very rarely see data sets like that. And if you do, you probably aren't going to do statistics on it because you know everything you need to know. Like if everyone in the class got an 80, well, I don't need to calculate the mean. I don't need to calculate the median. I don't need to calculate the standard deviation. Like there's nothing much to know. You're like, well, everyone in the class got an 80. That's kind of the whole story, right? It's once your data values are changing that it becomes interesting to use statistics, and that's most of the time. Most of the time, you don't get your whole data set being identical values, okay? So basically what a z-score does is it allows us to have a ruler, like a ruler, like a measurement, like if you're gonna, you have a 1 foot ruler and you put it up to the wall and you can measure how long your wall is by putting the ruler end to end down the wall. You're measuring how long your wall is in feet, right? Well, a z-score is a way of measuring how far a data point is from the mean. You go, okay, well, but then what's my ruler in that case? What is my unit of measurement? How am I measuring how far a data point is from the mean? And the answer is the standard deviation is our ruler. Okay, that's the unit that we use. So just like you might ask, how many feet is this end of the wall from this other end of the wall? And you would measure with a ruler and you would count feet. What you're going to do is ask, how far is this data point from the mean in standard deviations? Is it half a standard deviation away? Is it 1.7 standard deviations away? Maybe it's an outlier and it's like 3 standard deviations away from the mean. Okay, so you would expect outliers to have a very high z-score, or an absolute value, a high value. And you would expect things that are near the middle, kind of your typical values, the stuff that's center, you would expect that to have a low z-score, like a z-score near 0. Okay, now here's how we calculate it. Now these, you go, man, I got 2 different formulas. Remember, we have different symbols for samples versus populations. So it's actually the same exact formula. It's just that one is given in the language and symbols, the notation of samples, and one is given in the notation of population. But it's the same exact thing. You take your data point, you subtract the mean. Remember, when we do subtraction, when we do a difference, that gives us a distance, right? So if you're driving and at one point you're at a 100-mile marker on the freeway, and then a little while later you're at the 60-mile marker, then if you subtract those, you can figure out that you went 40 miles, right? We get that by subtracting those two. Well, that's what we're doing here. You're taking the data point that you're interested in and you're subtracting the mean. Okay, now what that means is some of your z-scores will be positive, because if your mean is if your data point is greater than the mean, then when you do this subtraction here, you're going to get a positive number. But if the data point is less than the mean, then when you do the subtraction, you get a negative. So that sign on your z-score, whether it's positive or negative, without doing anything, just by looking at the sign on the z-score, you can tell whether your data point is above the mean or below the mean based on, is your z-score positive or negative? Okay, and just thinking about this numerator. How would I get a negative? Well, I'd get a negative if my mean was greater than my data point. How would I get a positive? I'd get a positive if my data point was greater than my mean. Okay, and then remember this S, we're dividing by the standard deviation. So you take whatever this distance is on top and you divide by the standard deviation. That will tell you how many standard deviations away your mean is from the mean. How far your data point is from the mean, right? Just like if you measured your wall in inches and then you divided by 12, that's going to tell you how many feet it is, right? Well, that's what we're doing here. We're taking that difference, dividing by the standard deviation. That tells us how many standard deviations away from the mean our data point is. This allows us to figure out which data points are more extreme than the others, because like I said, you expect if something's an outlier, you might see it have a z-score of 3.1, or maybe it's on the other side of the graph, so maybe it's a z-score of negative 3.2, but it's not near 0. The closer your data point is to the middle of your graph, the closer to 0 your z-score is going to be. If your data point is the mean, well, then your z-score is going to be 0 because the distance from the data point to the mean is 0. And then, they start to spread out from there. So this means if you're trying to figure out, you have 2 data points, you're trying to figure out which one's more extreme, which of these is more unusual, calculate the z-scores. And whichever one is further from 0 is a more unusual data value, okay? Depending on your set, sometimes it's hard to talk about statistics because I say these things, and then you could come up with an example where, if your data is like in a ring or some kind of weird shape, where, you could say, well, it's a little different in this case. That's always true with statistics, but that by and large, what I said holds true. So let's do an example of calculating a z-score, right? How would we do this? So I've got the example I just made a minute ago. These are a hypothetical English scores, and then let's say math scores. And again, hypothetical. Okay, two sets of scores here, right? So you got two friends, 2 buddies, right? One's taking an English class, one's taking a math class. So this is our hypothetical scenario right here. And they meet up after class. One came from his English class, one came from his math class, and they're both proud of themselves because they both just did good on a test, okay? So the person from the guy from the English class is like, man, I just got a 97 on this test and I got the highest grade in the class. I'm so proud of myself for what I did. And the other friend's like, hey, I just had the same thing in my math class. I just scored the highest grade in my math class, and I did better than everyone else, right? So that's good. They both can have something to be proud about. But, as sometimes people do, they get a little competitive and start trying to figure out who has the better accomplishment, right? And you got one person going, well, I scored a 97 and you in my English class, and you scored a 94. So that means that my accomplishment is bigger than yours. And then the other person's going, yeah, well, mine was in math, and math is harder than English, right? So again, this hypothetical situation, we all know how people can be when they're messing around with each other as friends and trying to outcompete each other, right? So you're trying to make the argument that your accomplishment is better than the other person's accomplishment. So how could we compare these? I mean, what is a scientific way for trying to make the case that one of these accomplishments is bigger than the other one, right? The case that math is harder. Well, that's subjective. Some people might think math is harder. Some people might think English is harder. This is, by this it's English language. I guess they don't call it English anymore. It's language arts. I forget what they call it, but anyways, right, so those are the 2 classes, and the person saying, well, I got a 97, that's near perfect, right? And they're going back and forth. Well, what we could do is we could calculate a z-score for each of these people, even though they're in completely different sets. That seems weird sometimes. I can compare these 2 values that are from completely different things. This math professor's grading system has nothing to do with this English professor's grading system. How on earth could you possibly connect the 2? Well, the z-score gives us a way to do that. So let's calculate the z-scores for both of these values, and then we'll see who has a greater z-score. What does that mean? That means that person is further away from the mean than the other person. And the further away you score from the mean, that you could make the argument that, well, that's more exceptional that I did. So let's see. Let's run our stats. So I'm going to do summary stats for columns on the English. Let's see. Should I forget? Can I do both at once? Let's compute it. Oh, yeah, here we go. Both at once. That's convenient. So I've got my summary stats here. I've got my English. So if you just hit, in case you haven't figured this out, if you hit shift, it's kind of like it is just in computers in general. If you hit shift, you can usually highlight multiple things at once. So that's all I did to get English and math at the same time. I highlighted English, shift, and then highlight math, and then they're both highlighted. Okay, so what do we see? Well, the mean for English is significantly higher, and the mean for math is lower. The standard deviation for English is lower, and the standard deviation for math is bigger. Okay, so it's kind of hard to, you're kind of trying to figure out, okay, what would that mean when we're doing this? It's still not completely clear what it is that we're talking about. So if I wanted to calculate a z-score, remember our formula. You take the data value, that's our x, minus the mean, and divide by the standard deviation. Okay, so let's walk through that. I've got my StatCrunch here. Let's get a calculator out. Okay, so our data point over here, we're wondering what the z-score is for this person who got the English score. So 97 minus, okay, what was the mean in there? Was 82.9. 82.9 equals. So there's a distance of 14.1 between the mean score in the English class and this individual's score. So 14.1. So that's the numerator part of our formula. I just did this numerator, x minus x bar part. Now we're going to divide by the standard deviation. So, oops, I got to get my calculator back here. So now we're going to take the 14.1 and we're going to divide by the standard deviation over here, 5.952. So divided by 5.952 equals. So we get 2.3. So let me just make a note of that. Where's my scratch paper here? So 2.36, I guess it'd be 2.37 if we're rounding properly. 2.37 is the z-score for the individual from the English class. Okay, now we're going to do the same thing, but for the person from the math class. Okay, so I'm going to hit clear. And okay, so the data value we're concerned about in the math class is a 94. And the mean is 73.2. So 94 minus 73.2. So we now have a distance from this score to the mean for that particular class of 20.8, right? Notice when you do the z-score for the English class, you use that mean. When you use the z-score for the math class, you use that mean. Use the information from the corresponding set, okay? So we've got 20.8. Now I'm going to divide by the standard deviation for this class, which is 9.3. So divided by 9.3, hit enter, and we get 2.23. So actually these were really close together for something that I just made up on the spot. 2.23. So the English score was 2.37. The math score was 2.23. So, you know, by the only means we really have of comparing things that are completely different like this, the person from the English class could make the case my score was actually better, right? Because my z-score is higher. I'm more standard deviations above the mean than you are in your class. And actually, I kind of had meant for it to come out differently. But it's entirely possible that you can have, like, even though the 94 scored lower than the 97, it's entirely possible that this could have a bigger z-score. In fact, let's see if I can make that happen. It's kind of what I intended. I think it's because I made the standard deviation so big. Let's move this back to like 65. Maybe make this like 72. Let's just see if that's enough. So I go summary stats columns, pick both again, compute. Might have made a difference. Let's see. So when I do the math one again, I'm going to get 94 minus 74.3 divided by 8.13. Now that z-score is 2.42. So even though I just changed a couple values, the math z-score is now, could argue, well, I have a higher z-score. I'm more standard deviations above my mean than you are standard deviations above your mean. That means I did more excellent right? Or whatever way you want to talk about it. So z-scores can be super helpful both for comparing things inside the same set, but actually we have this power of comparing things from different sets, which you don't do all the time, but when you do it, it's helpful because there's really no other way to compare these things in an objective scientific way. I mean, you can sort of try to make some kind of reasoning, but it's not really objective reasoning, right? So that's what the z-scores look like. Again, super easy to calculate. Very, very easy to go through and calculate those things. Okay, like in here, so in their example, they're comparing a height and a weight. How else could you compare a height and a weight except for calculate z-scores for them and figure out which one is more unusual, right? You might go, why would I want to do that? It's just a lot of times in life you want to compare two things. You have to make a decision about which thing to address maybe at your company. We got two issues right now. Which one's the bigger issue? You figure it out and go, okay, this one's affecting our assembly line more than this other one. And then you go take care of that, okay? We're kind of going to call, in general, this is just a rule of thumb, but in general, your ordinary values, if something is within 2 standard deviations of the mean, it's pretty typical. It's kind of normal. Once you get a z-score above 2, that means you're 2 standard deviations above the mean or more, or lower than -2, so that would mean you're 2 standard deviations or more below the mean. Then we start paying attention to those values because you're kind of starting to get into the area of outliers, not necessarily, but like kind of in that zone where you're like, well, maybe we should take a look at these. Whenever you have a data set, if you have weird points that don't seem to follow the pattern, looking at those weird points can give you insight into the rest of it because you go, oh, now I understand why this point is different. That gives me some light on how the rest of these are all the same. And then you've just learned something, right? So the higher a z-score, if it's above 2 or below -2, take a look at it and see if it makes sense. Right. Okay, next idea is percentiles. Percentiles are helpful. They can sometimes be confusing to students. I won't go over in great detail how to calculate them because you should have homework problems on how to do that. So you can go through and check out the actual calculations. But I'm going to give you some insight as to what's going on and try to explain the way percentile questions can be tricky because changing 1 or 2 words in the question can like flip the whole problem around. Because there's basically 2 things you want to do. Say you have a data point and you want to calculate its percentile. Okay, so that's doing it one way. You start with the data point, you calculate the percentile, but you can turn that question around and you can start with a percentile and figure out what the corresponding data value would be. One of those calculations is significantly easier than the other, but they are different. Meaning if you're going to do a problem like that, you have to figure out ahead of time, okay, which way am I doing this? Am I trying to figure out a percentile or am I trying to calculate a data point? And you can't really start the problem until you've answered that question. Okay. So what is a percentile? Percentiles are measures of location, denoted P1, P2, up to P99, which divide a set of data into 100 groups with approximately 1% of the values in each group. Kind of weird they don't have a period at the end of that sentence, but so what this means is it gives you roughly an idea of what percentage of your data is located in a particular area. And the easiest way to do it is to think of it, usually the way it's used is what percent of the data is below a certain point. Okay, so the way they used to, I don't know if they still do this anymore, it's a long time ago, but the SATs used to be reported, you would get a score, and then they would also tell you where the percentile is because it varies from year to year how the overall scores do. And unless you get a perfect, an individual score on the SAT doesn't really matter because what matters is where that puts you in relation to everyone else. So like at Stanford, they're like, we only want to take I'm making this number up, but let's say we only want to take people that are in the top 3% of SAT scores. Well, they need to know where that cutoff is. What is the cutoff where we want people in the top 3%? If you score below this, you're in the bottom 97%. The admissions counselors at Stanford need to know what that score is, right? So that's a case where you would start with a percentile and then figure out the data value that corresponds to it, and any work coming in that doesn't meet that, you just toss it in the trash. Go, oh, sorry, you're not going to Stanford. I hope you picked another school. They'll figure the cutoff that way, right? But when it's presented to you, when you get your SAT score, what they did was they took your data value and calculated a percentile. So you get your score and it says, you've scored better, or 90% of the people who took the SAT got a math score lower than yours, or whatever your particular score happens to be, right? So they give you a value and then the percentile. So that's what these percentiles do, is you can figure out 37% of the data is below this value. 87% of the data is below this value. And it helps you sort of, like I said, like with the Stanford scenario, they figure out, we just want the top 3%. So they figure out the 97th percentile, whatever that cutoff is. We only want scores this one or better. And and then they all kind of agree to follow through with that. So this might sound familiar. The 50th percentile is a very special value. You already know it. It's called the median. The median splits your data in half. Well, what does that mean? That means 50% of the data is above the median, 50% of the data is below the median, right? Remember, I kind of talked about people think the mean does that, but then we looked at examples that doesn't work. You can come up with values where 80% of the data values are above the mean. But the median, that's the definition of the median. 50% above, 50% below. And so the 50th percentile is also the median, okay? Also know that percentiles are a little inexact. In fact, there are actually different ways of calculating percentiles. If you look in different books, they have slightly different rules about rounding and calculations, but they all come out about the same. But percentiles are sort of an inexact way of doing mathematics anyways. When we use percentages is kind of just like pseudo math. It's really to help people understand the math that you're doing. It's not really a good way of actually doing calculations. So percentiles are a little bit inexact, but the reality is they're close enough, right? If you're one of these counselors at Stanford and you're saying we really only want the top 3% of scores, does it matter if you got someone who was in the top 3.1% of scores? Probably not. That person is probably still very good, right? So it's just a way of roughly getting a baseline where you can create a cutoff for a certain thing, okay? Right, you're going to use StatCrunch to find this kind of stuff, so it's a little bit more straightforward. If you're calculating these by hand, you have to put everything in order. Then you have to order your data, and you can order stuff in StatCrunch pretty easily. So like, see how this column right here is not ordered? You can just go in. In fact, now I have to remember where it is. I'm remembering I haven't done this in a couple months. Is it a range? Oh, sort. I think it's under sort. So let's see, I'm kind of over to the side. So if you're here, like let's say I want these in order for some reason. So I go to data and I come down to sort, and it says, well, do you want it sorted? How do you want it sorted? Do you want it ascending or descending? Ascending means going up. Like if you ascend some stairs, you're going up the stairs. If you descend the stairs, you're going down the stairs. Okay, so they want, like, which one do you want it, ascending or descending? And you, of course, this says all columns, but I could just select, I just only want the English column sorted. So I picked that one. And it says, well, how do you want us to output this information? Do you want us to replace your current column with the new sorted data? And you might, but you might also want that original unsorted data and the new one. Like, for instance, with the data that you get from the surveys, you're probably not going to want to sort them in the original column because you may still want to link up that response with other responses from the same person. And if you sort things, it mixes it all up. So what you might want to do is have them create a new column with that. Or it even says open in a new data table. We don't need to do that, but I hit compute. Oops. What did I not? What did I do wrong? Oh, because I didn't. Okay, never mind. Should have been the English one. Ascending, hit compute. There we go. And so now it said, oh, here's the sorted version of your class, and you can see it looks like I have it ascending. So it started at the lowest value, and then it's going in order up to the biggest value. That's especially helpful if you're doing things by hand, which most of your calculations will not be. But if you end up doing some because you're doing part of the homework and you're like, this will just be easier if I do it by hand, you can have StatCrunch sort it for you. Most of the time, StatCrunch, if StatCrunch needs to sort the data, it's going to do it automatically behind the scenes anyways. But that can be helpful, knowing that you can create that sorted data. Okay? Right, and for some of the homework problems, that may be especially helpful. So you've got, let's see. There's usually a big chart here. Yeah, oh yeah, here's the chart I was looking for. So there's like, you can find flow charts that kind of walk you through how to do these problems. But you'll see too when you're doing the homework problems or the lessons specifically, where they go through and give you some information on how to do that. Right, here's one about speed limits. So why might you use something like this? Well, you might want to know what percentage of values are sort of extreme, right? Say in this case, you've got speeding violations. Well, a lot of speeding violations are, for people that are going 5 miles over the speed limit. If you're going 5 miles over the speed limit, you're probably not a huge danger to everyone. But overall, they have to police that kind of stuff so that otherwise we just, if we knew we weren't going to get in trouble, you just go faster and faster. In California, you don't get much of this. Usually, you're not going to get pulled over for going 5 miles over the speed limit. But there are places where, it's part of how the state generates revenue for itself. California doesn't really do that. But, I lived in Washington State for 4 years. Washington State was notorious for, if you're over the speed limit, you're getting a ticket, right? Because that's one of, some of these states that don't have income tax, they have to make money somehow. So, okay, we're going to get you. If we see you 3 miles over the speed limit, you're getting a ticket. I think I got a ticket up there for being, I think it was 4 miles over the speed limit out on the peninsula. And I got pulled over for that. But overall, you're going to have this data as part of the city. You're going to have this data about your tickets that you're giving out. And, the city itself may wonder, what percentage of the tickets that we're giving are 5 miles per hour or less, right? Because you might want to know, maybe we shouldn't really be pulling people over for 5 miles an hour. Maybe that's actually more dangerous than people just speeding at 5 miles an hour, right? It's kind of dangerous when someone gets pulled over on the freeway and then the cop cars sometimes kind of sticking out in the lanes so they can protect themselves when they're talking to the person. Accidents happen that way and it can be dangerous. So, it's the safety consideration. You could easily have a situation where a committee looks at it and says, let's not pull people over for going less than 5 miles an hour over the speed limit. I know we're going to miss out on some revenue, but it's actually kind of dangerous to be parked on the side of the freeway. But let's just let those people go. And then, places like Washington where they're going to get that revenue if they can get it from you. So, you might want to know, well, where's the real problems? What percentage of our speeding tickets that we give out are actually dangerously on the road? You're going 9, 10, 15, 25 miles an hour over the speed limit. You could look at those cutoffs and ask yourself, what percentage of these are actually dangerous? And you could find the percentile and figure out what that is, okay? So you always think of these percentiles as what percentage of my data lies below this data point, right? What percentage of our data were people that were going less than 73 miles per hour, right? We could calculate that from what we have here. Quartiles. If you understand percentiles, quartiles are basically just built in. The quartiles are just your quarter percentiles. So your 25th percentile is your first quartile. Your second quartile, so here's where it gets kind of almost silly. Your second quartile is your 50th percentile, which remember is your median. So all three of those things are actually the exact same thing. 50th percentile, second quartile, median. They're all exactly the same. But then you have your third quartile. That would mean the third quartile means 75% of your data is below that value. All right, so quartile 1, 25% of your data is below that value. Quartile 3, 75% of your data is below that value. And then, of course, you could talk about the fourth quartile, but that's kind of silly because the fourth quartile would be 100% of your data is below that cutoff. Well, that's just the highest value in your set, right? So you already know that is the maximum. So really, we usually only talk about the first three quartiles because the fourth quartile is kind of silly. That's just the whole thing, right? So you can find a quartile the same way you find a percentile, except, you know,